Hello dear students, this is Ramesh Rajur welcoming you all to the third part of the question paper, that is 2 marks question section. Today let us solve all the 2 marks question from the model question paper of the 2023 and 24. In this section, in the first question is we have to prove that 2 plus root 3 is irrational. To prove this one, we have to assume that 2 plus root 3 is a rational. Assume 2 plus root 3 is a rational. When this will be a rational, this can be expressed in the form of a by b, where a and b are integers, and denominator b is not equal to 0. Then 2 plus root 3 can be written in the form of a by b, because we have assumed that 2 by root 3 is a rational. Rational means it can be written in the form of a by b. Now transform this left hand side plus 2 towards the right hand side. That becomes root 3 is equals to a by b minus 2. Later on, that becomes root 3 is equals to the LCM of the b and 1 is b 1's time or b, and 1 into b time or b. Therefore, a into 1 is a minus 2 into b is 2b. Here, comparing the left hand side and the right hand side, we have in the left hand side we have irrational number, where in the right hand side we have a minus 2b by b. Here a and b are the rational, therefore the operations among the rationals, it may be a additional, subtraction, division or multiplication. Any 4 operations from the rational gives again a rational. Therefore, in the left hand side we have irrational, where in the right hand side we have rational, which is contradict to our assumption. This is contradict to our assumption. We can say that 2 plus root 3 is irrational. In the same numbers, that is 17th question, we have OR question. Here we have find the HCF of 64 and 332 by using Euclid division algorithm. By Euclid division algorithm, we know that A is equals to BQ plus R, where A is a dividend, P is a divisor, Q is a quotient, and R is the remainder. In the given example, we have 64 and 332. 64 and 332. Let's, in the first stage, the divisor will be 64 and the dividend will be 332. That is, what we know is A is equal to BQ plus R. By dividing the 332 by 64, we have 332 into 5. 64 5s are 320. Remainder will be 12. In the first stage, what we have is 332 is equals to 64 into 5 plus remainder 12. That is A is equals to BQ plus R. Later on, the remainder will become the divisor and the previous divisor becomes dividend. That is 64. Here we have 12 5s are 60. Again, we get the 4 as remainder. That is in the second stage, we have 64 is equal to 12 into 5. That is A into Q is 12 into 5 plus the remainder is 4. Later on, continuing the same procedure as we done in the previous step, the 4 becomes the divisor and 12 becomes the dividend. That is 4 3s are 12. That is in the third stage, we have 12 is equals to 4 into 3 plus remainder as 0. The last divisor will be the HCF of given numbers. That is 4 is HCF of given two numbers are 64 and 332. 332. 4 is the HCF here. Moving to the next question, solve by the eliminating method. Here we have two equations, 2x plus 3y is equal to 14, and second equation is 2x plus y is equal to 10. Comparing the coefficients of the x here, we have 2 as same number, so subtracting the second equation from the first equation, we have plus 2 and minus 2 get cancels. We left with here as 2y is equals to 14 minus 10 is 4. That is equal to y is equal to 4 by 2. That implies y is equal to 2. Here the first equation, that is 2x plus 3y is equals to 14. 2x plus 3 into the value of y is 2 is equals to 14. Later 2x is equal to 2x plus 6, 3 2s are 6 is equals to 14. 2x is equals to 14 minus 6. When the left hand side plus 6 comes to the right hand side becomes minus 6. That is equal to difference between 14 and 6 is 8. That is 2x is equals to 8 and that implies x is equals to 4. 2 1s are 2, 2 4s are 8. Therefore, we get the value of x as 4. Moving to the next question, find the sum of first 30 terms of the arithmetic progression 3, 7, 11 using the formula. Here, from the given arithmetic progression, we can see that the value of a, the first term is 3, and d, the common difference is a2 minus a1, that is 7 minus 3 is equals to 4. And the number of term they have given to find is 30. Therefore, first term is a is equal to 3 here. The formula to find the sum of the given numbers is Sn is equals to n by 2 into 2a plus n minus 1 into d. Substituting value of the a, d and n in the given formula, that is S30 is equals to 30 by 2, 2 into a is 3 plus n is 30 minus 1, d is 4. Simplifying this one, we get 2 1s are 2 15s are 2 15s are 30, 2 3s are 6 plus 29 into 4. 29 into 4. That give rise to 15 into 6 plus 29 fours are 116. The next further steps, we get S30 is equals to 15 into 122. 15 twos are 30, we get 3 carry. 15 twos are 30 plus 3, 33. 3 again remains the carry. 15 ones are 15 plus 3 is equal to 18. That is 1830. 1830. Moving to the next question. Find the roots of the equation x square minus 7x plus 12 equal to 0 using quadratic formula. We have a, b, c from the given equation as a is equals to 1, b is equals to minus 7, and c is equals to plus 12. The quadratic formula to find the roots is x is equals to minus b plus or minus square root of b square minus 4ac divided by 2a. Substituting the value of the a, b, c in the quadratic formula, that is minus of the value of b is minus 7 plus or minus square root of b square, that is minus 7 square minus 4 into a is 1 and b is 12. 4 divided by 2a. 2 is 2 and 1 a is 1 here. Simplifying this one, we have x is equals to plus 7 plus or minus the square root of 7 square is minus 7 square is 49 minus 4 ones are 4, 4 twelves are 48. That is, in the denominator we have 2 ones are 2. In the next step, we have x is equals to 7 plus or minus square root of 1 by square root of 1 by 2. That implies x is equals to 7 plus or minus the square root of 1 is 1 by 2. In the later, we have 7 plus 1 by 2 or 7 minus 1 by 2. That implies we have two roots here. X is equals to 8 by 2 or x is equals to 6 by 2. If it is 8 by 2, we get 4, and if it is 6 by 2, we get 3. Therefore, the roots x is equals to 4 or x is equals to 3. Moving to the next question, prove that sine 30 plus cos 60 plus tan 45 is equals to secant 60. Here we have the value of sine 30 as 1 by 2 plus cos 60 as 1 by 2 and tan 45 as 1. In the right hand side we have secant 60. The value of secant 60 is 2. The sum of the left hand is 1 by 2 plus 1 by 2 plus 1 is 2. In the right hand side we have 2. Therefore, LHS is equals to RHS. After proving the first part, here we have OR question. In the OR question, we have to prove that cos A by 1 plus sin A plus 1 plus sin A by cos A is equals to 2 secant A. To prove this one, consider the left hand side. Consider left hand side, that is cos A by 1 plus sin A plus 1 plus sin A by cos A. Here, taking the LCM of the Denominator we have 1 plus sin A, 1 plus sin A into cos A. When multiply cos A into cos A, we get cos A, cos square A plus 1 plus sin A whole square, sin A whole square. Later it becomes cos square A, cos square A plus 1 plus sin A whole square in the form of A plus B whole square. The expanded form of the A plus B whole square will be A square, that is 1 square, plus B square. Here B is sin A, B square will be sin square A, plus 2 times of AB, that is 2 times of A is 1 and B is sin A. In the denominator, it remains same, that is as 1 plus sin A into cos A. Next, cos square A, that is cos square A plus sin square A is 1 plus 1 square is 1 plus 2 sin A. 2 sin A. In the denominator, it remains same, that is 1 plus sin A into cos A. That is equals to 1 plus 1 is 2, 2 plus 2 sin A by 1 plus sin A into cos A. Here, taking the 2 as common in the numerator, we remain with 1 plus sin A by denominator will be same, that is 1 plus sin A into cos A. 1 plus sin A and 1 plus sin A get cancels. We remain with 2 by cos A. 2 by cos A is nothing but 2 into secant A, because the reciprocal of cos A is secant A, or we can use 1 by cos A is equal to secant A. This will be required right hand side. In the next question, we have find the coordinates of the points which divides the line segment joining the points 2, 1 and 7, 6 in the ratio 3:2. Here, we have to use the section formula, that is x1 is equals to 2, y1 is equals to 1 and x2 is equals to 7, y2 is equals to 6 and m1 is equals to 3 and m2 is equals to 2. Suppose this is the line AB and the coordinates of the point A are 2 and 1 and B are 7 and 6. Here, let us consider the point P here, P, which divides the line AB in the ratio of 3 and 2. We have to find the coordinates of point P of xy. That is, we know that the section formula, that is P of x into x comma y is equals to m1 into x2 plus m2 into x1 by m1 plus m2. Similarly, the coordinates of y, that is m1 y2 plus m2 y1 divided by m1 plus m2. Substituting the value of x1, x2, y1, y2 and m1 and m2, we have m1 into x2, that is 3 into 7, 3 into 7 plus m2 is 2 and x1 is 2 divided by 3 plus 2. M1 is 3 and M2 is 2. M1 is 3 multiplied with Y2. Y2 is 6 plus M2 is 2 multiplied with Y1. Y1 is 1 divided by 3 plus 2. Simplifying this, we have P of xy is equals to 21 plus 4 by 5 and 18 plus 2 by 5. That implies 25 by 5 and 20 by 5. That gives rise finally the coordinates of the point P as 5 and 4. The value of x is 5 and the value of y is 4 here. Next question. A box contains the token which are numbered from the 1 to 15. A token is drawn at a random from the box. Find the probability that the token does not bear a prime number. Here we have totally the 15 tokens. That is number of S is equals to that may be 1, 2, 3 and like so on up to 15. That is 15, 15. And a token is drawn at a random from the box. Find the probability that that the token does not bear a prime number. It should not be a prime number. Suppose we consider the prime numbers between 1 and 15. We have first prime number as 2 and later 3 and next is 5, 7, 11 and 13. These are the prime numbers between 1 to 15. Here we have to select the number that is not a prime number. That is, let us consider them by the letter A. The not prime numbers, the numbers which are not primes, are 1, 4, 6, 8, 9, 10, 12, 14 and 15. Total they are 1, 2, 3, 4, 5, 6, 7, 8, 9. They are 9 in number. Therefore, a probability of a number which is a not prime number is P of A is equals to N of A by N of S. That is 9 by 15. Later we can write as 3 3s are 9 and 3 5s are 15. 3 by 5 is the probability of number which is not a prime number from the box. Next question. Draw a pair of tangents to circles of radius 4 cm which are inclined to each other at an angle of 60 degree. First draw a circle of radius 4 cm. At the center of circle O, draw an angle of 120 degree because 180 minus 60 is 120 degree. Let it be the 120 degree. Join OA and OV be the radius. Draw the perpendicular lines for OA and OB at the point of circumference. The perpendicular lines let them join at point P. Therefore, PA and PB are the required tangents. Thank you for watching the video.